before proceeding these kind of pairing. That was about the first topic. Next topic we have is network security. And in this chapter, we have NSGs. We are still talking about the network security. So far, it's just the perimeter security. So that means we still have more components to protect your network. So now we are talking about the inner level of the network: segmentation, subnets, individual workloads. The first service we have over here is NSG, Network Security Group. In NSGs are also like a small firewall, or you can say basic firewall, because it does limiting, or it can limit the traffic same as firewall. But firewall is a big time service. It's an advanced service, whereas NSG is something having a basic capability. It also limits the traffic. Now, another difference is when it comes to association. Firewall is applied on the network level, whereas NSG is being applied on the subnet level and network interface level. So these are the differences you have to keep in mind. When it comes to two similar services, make sure you know the differences between them. Next one is how your NSG is going to limit the traffic. Now, definitely, in order to limit, you have to let it know. You have to make some rules. So make the rules to allow or deny the traffic. And this time, the rule will be created based on 5 tuples. You have to create 5 tuples. 5 tuples means source port, destination port, and protocol. Along with that, what action you are going to take? Do you want to allow the traffic or you want to block the traffic? Secondly, what would be the priority? As you may have multiple rules, how about the priority for those rules? So you have to define the priority and the precedence order. This is called precedence order. It's just an integer. So whenever you create an NSG, there would be some rules which will be there for you. Those are called default rule, default inbound rule, and default outbound rule. You can't control or you can't delete those rules because this is something created by Microsoft and you are not allowed to modify them or delete them. But in order to override such rule, what you can do is you can create your custom rules. You can create your customized rule to avoid these type of default rules. Another most important thing about NSG is association. Like I said, NSG can be placed across subnet level and NIC level. Sometimes people get confused at how it's going to work if we have NSG on both levels, how the evaluation takes place, how the traffic will be evaluated. So do remember, NSGs will be evaluated independently from subnet and for the subnet and NIC level. Like according to this diagram, what do you see? You see we have NSG1 and NSG2. NSG2 have been placed on the subnet level. This is a subnet level NSG. NSG1 is lying on the NIC level, on the VM level. Now both NSG have different rules. For example, I'm talking about the rule for RDP. We have a rule for 3389. If you have the rule for 3389, that will be allowed by NSG2. But maybe your NSG1 doesn't have that rule. If your NSG1 does not have the rule for 3389, then 3389 will be denied. So do remember, whenever it comes to NSGs, and you want to allow the traffic, so make sure the allow rule must exist at both levels for traffic to be admitted. Otherwise, the traffic will be denied. So these are the key pointers which we have to keep in mind while having two NSGs together. Sometimes we face challenges with multiple rules. So how can we troubleshoot such NSGs? In that case, for troubleshooting purpose, we have this. We have many tools, but one of the tools is effective security rules, where you will get to know all the rule details, whatever the rules working effectively that you will see over there. It's a part of network watcher. It comes under network watcher service. So this is about NSGs, network security group. Other option we have is application security group. Now let me show you this on the portal and then we can move forward. I'll take you back to the network security group, NSGs. This is one of my NSG. And like I said, in the NSG, you have to define that what rule you're creating or what rules are there. Secondly, where it is associated. It can be applied on the subnet level or on the NIC level. Now you see, if I click on the inbound rule, you will find that there are 3 rules which have been grayed out because I won't be able to delete them. You see, it's the default rule. Same goes for outbound. These are the outbound rules. You can't delete them. So whenever you want to override these rules, then make sure you create a rule with low integer that will get high priority. You can't delete default security rule, but you can override them with the rules that have higher priority. And once you make the rule, then you have to associate it. So either you apply the rule on the NIC level or on the subnet level. Sometimes, for example, we have multiple VMs. Maybe I have 20 web servers and I have 20 application servers. Now I would like to allow the traffic. I would like to distribute the traffic, or I would like to filter the traffic for those web servers to application servers. Maybe I want that all the web server traffic needs to be sent to a particular destination called application service. So when it comes to many VMs, are we going to create the rules individually for all the VMs? Maybe your VM doesn't belong to the same subnet. What if it belongs to the same subnet? How you are going to combine multiple VMs together? So when you have multiple VMs, you can group those VM logically using ASGs. ASG means logically grouping of your VM, like your web servers, your application servers, and then you can combine the rule along with that. So the purpose of ASG is all about logical grouping of your services. According to the diagram, you can see here we have VM1, VM2. These VM1, VM2 belongs to ASG web. These are my web servers. So they have kept these 2 VM in ASG web. As these are the web server, the traffic which is coming from the internet, which is allowed to the web server. You see the green tick mark over there. So we are not setting up a dedicated NSG for that. We have NSG1 where we are creating the rule for these 2 ASG. One rule will be enough for 2 VM. If we have 10 web servers, again, one rule would be enough. And secondly, on the other side, you have this logic. Now, logic VM doesn't need to, you can say, we don't want to allow any traffic from the internet to the logic VM. So we haven't created that rule over there. And all these rules will be created in one NSG for multiple servers. So the main purpose of ASG is to reduce the number of NSGs, rules, and to manage your multiple VMs. That is called ASGs. So to wrap the ASGs with NSGs for more security. That's what the main agenda. Next, we have few more networking services. One of the services called endpoint. We have service endpoint and private endpoint. Two concepts are there. The service endpoint is also a part of another chapter. So I'll give you the you can say an idea over here. And on the next chapter, we'll talk about one demonstration. The concept of service endpoint comes into a picture when it comes to optimal routing for your services. You want to send the traffic over Microsoft backbone. Take a look on the diagram to understand the service endpoint. According to this diagram, this is your storage account. This is the service called storage account service. In this particular service, you have a huge amount of data. Now, you do not want to allow that anyone can access the storage account data over the internet. You want people can access the storage account data over Microsoft backbone network using service endpoint. So what they have enabled the optimal routing for this storage account to the service endpoint. That means the storage account can only be accessible from one network, one subnet. Have a look on the statement called optimal routing for Azure services from your network. That means my service will not be accessible from anywhere except Azure network, one particular subnet of your network. So that improves the security because now your service is not accessible from anywhere else. It will be only allowed from a secured network from your Azure network only. So overall, the intention is that we want that traffic should be, the routing can be allowed through Microsoft backbone. This concept is quite simple to create. It reduces the management overhead. And this is something about, you can say, enabling the security across your services, restricting your services to Azure backbone only. But service endpoint has few limitations as well. It has few restrictions as well. Service endpoint can only be applied to few services. Like right now, according to the diagram, they have just shown the storage account service. So only few PaaS offerings are allowed using the service endpoint. Maybe a database, maybe a storage account, maybe a key vault service. So there are 10, 11 services which can be enabled using the service endpoint. Let me show you these services on the portal. So when you go to your network, VNet, and when you create a subnet, along with the subnet, you get the option to define the service endpoint. Do you want service endpoint for the subnet or not? So this is the option right here, service endpoint, create service endpoint policy to allow traffic to specific Azure resource from your network. Now, as per my example, which service resource we were talking about? We were talking about storage account resource. So you can see this Microsoft.storage has been enabled. What are the other services I can access from my selected network? I can access Key Vault, Service Bus, SQL, storage account service, web application. These are the services, containers, Cosmos DB. So only these services can be used, can be accessible over Microsoft backbone using service endpoint. Overall, there are some restrictions, limited services are there. The service endpoint take time as well. It will take 15 minutes to complete, to enable. And this is something I was showing you. These options come into a picture when you go to your dedicated subnet and where you want to enable the service endpoint. Next, we have private endpoint. Private endpoint means, again, it's a concept where we are talking about security, restricting the, trying to optimize the traffic. Private connectivity to the Azure services. So the intention of private endpoint means, in terms of service endpoint, we are just talking about limited services, and we were talking about you can say, few PaaS offerings. Along with that, we can't define the service endpoint will enable for the complete service itself. In private endpoint, you get some more enhanced features. Traffic will remain on Microsoft network with no public internet access. There is no requirement of public access to your services. The traffic will remain on Microsoft network. Secondly, this can be integrated with on-premises and peer network. This also works with on-premises. In this case, we actually bring the service inside a network. We make a service a part of your network. For example, I have a data storage account. Ideally, storage accounts will not be a part of a network. So what we do in this case, we make a private link, we make a private endpoint, and we associate a NIC to your service. We associate a IP, a private IP to your resource. So it could be your storage account service, it could be your on-premises service, it could be your, you can say, cloud services. We bring that service into the network. And this is why it's called private endpoint. So this has more capability as compared to service endpoint. Next, we have load balancing services. When it comes to balancing the load, we have different type of load balancer exist on cloud. We have 4 type of load balancer exist. And you have to make a right decision to choose the right load balancer. So if you go to your portal and if you go to your load balancer service, Microsoft offers you a very good interface to choose the right load balancer for your environment. So this is called Help Me Choose window, where they actually ask you a kind of questions, or it's a kind of a questionnaire to choose the right load balancer as per your requirement. They'll ask you a question, you have to answer them, and then they suggest a particular load balancer which is best for your environment. For example, they are asking that does your application uses HTTPS? I say yes. Is it a public facing application? I say yes. Is your application deployed in multiple regions? I say no. Then which load balancer they have recommended? They recommended application gateway for. I want to start it over again. Does your application uses HTTPS? No. Is it a public facing? No. Then what service they are recommending? They are recommending load balancer service. So load balancer means it's a layer 4 load balancer. These are the 4 services in front of you: load balancer, application gateway, front door, and traffic management. So when you get started with the service, you have to choose that which load balancer would be best for my environment. Either you go for this help me choose window, go and answer these questions to find the appropriate service, or you can just see this comparison chart. You can see that which service would have, or which service have which kind of features. It's a comparison chart. First of all, this is load balancer that's supported for layer 4 TCP UDP, whereas application gateway front door support HTTP HTTPS layer 7, whereas traffic manager is for NE. It is a DNS based load balancer. Does it support private load balancing? Load balancer support private load balancing. Application gateway support private load balancing. Private load balancing means internally, which is not over the public internet. Global load balancing can be done using front door and traffic management. Now, I will give you you can say, another information over here. As you can see, the global load balancing for load balancer, but it has limited features. Microsoft does not recommend Azure Load Balancer for global routing purpose because there are limited things available, limited features, and this feature available to some locations, only few locations. So whenever you talk about the global load balancer, Front Door, and Traffic Manager would be the best choice. How it's going to route the traffic? What are the routing policies? So we have round robin in Application Gateway. In Front Door, we have these many options. Load Balancer uses hash-based algorithm, and Traffic Manager uses geography, latency, weighted subnet, net value, multi-value priority. These are the routing methods. How exactly it's going to route the traffic to the destination? What are the supported environments? Now you see, except load balancer can only work for Azure. Other load balancing supported across any environment, Azure, other cloud, on-premises. So you need to understand the differences over here that you can check. If you want to know about the tutorial, you can see some of the tutorial right here. Now let's go to the presentation. This is called Load Balancer, Azure Load Balancer. It's a layer 4 service, and we can use the load balancer in two forms, internal load balancer and public load balancer. So this one at the top is called public load balancer. Public load balancer means which can distribute the traffic from the public internet, traffic which is coming from the internet that is being distributed to multiple workload. Another one is internal load balancer that is distributing the traffic to your internal, you can say, VM. So that means here we have no public IP associated. On the top, it's a public one, so it has some public IP assigned to it. But do remember this load balancer, as you can see, that is lying in a network only. It's a part of one network. And you can see this load balancer we can only use for Azure environment. It can't be used for any other environment. It only works for Azure VM, VMSS, and for container services. That should exist on cloud. When it comes to balancing the traffic, it balances the traffic based on 5 tuples, or it uses a hashing algorithm. Another application, another load balancer is layer 7 load balancer. This is called application gateway. Don't get confused with the name. It's just an application layer 7 load balancer, L7 load balancer. As it is a load balancer for layer 7, that means the protocol are getting changed. It has different protocols supported. HTTP, HTTPS protocol. And as for the diagram, you can see on the back end, this one, on the right hand side, we have a backend pool. This backend pool containing Azure VM scale set, on-premises machines, and Azure App Service. It also supports on-premises machines as well. It also supports app services, the PaaS offerings as well. So here we create a rule, and you can see the first elements that we create over here is called listener. Listener means what type of traffic it's going to listen. And further, it will be encrypting or decrypting the traffic like that. So it's overall, it's a kind of a web traffic load balancer, URL based load balancer. It has two different routing methods. One is called URL based routing, other is called multi-site routing. It also offers you session affinity, connection draining. Connection draining means how gracefully it removes the VM from your backend pool. And these are the rules you have to create. You have to make a rule for HTTP, HTTPS. If it's HTTPS, then you have to create the application, you can say your certificates as well. If you don't have, then make HTTP rules. Along with this application gateway, you can see on the background, this is something they have highlighted. They also have firewall configuration. That means with layer 7 For your application, we can also use web application firewall. WAF can be integrated. That's the one. It's a layer 7 firewall. And in this firewall, you can say, it's all up to you. Do you want to use that firewall or you don't want to use it? It's an optional feature. For added security, Microsoft always recommend you to use that. So this firewall will work in two modes, prevention mode and detection mode. And in this WAF, it works based on OWASP, Open Web Application Security Protocol. Top 10 protections are there. Along with that, you can make your own policies. You can make your global policies, custom policies that can be applied. So this WAF is going to protect your environment from cross-site scripting, SQL injection that can be created, that can be protected over here. But that actually works based on OWASP rule set 3.1, 3.0, 3.29. Now do remember this WAF we cannot use with a load balancer. It can only be used with front door service, application gateway service, or CDN. With these three services, your WAF can be integrated. Next, we have Azure Front Door, another load balancer. Again, this load balancer, it's also for layer 7 load balancer, but the difference is this time it's a global load balancer. Here we are talking about the workload which is being distributed across the globe. And it's one of the commonly used load balancers in the market. Microsoft itself uses this service for their internal users. So it actually offers you accelerated application performance with any cache or split TCP. It actually route your request, or it actually distribute your traffic to the appropriate backend pool quickly because it works based on split TCP concept. And here we use the concept of POP location, point of presence locations. You may have heard about CDN locations, edge locations, POP locations. So Microsoft have almost 130 POP location all over the world. Whenever the users try to access the application, the redirection will take place. Using the POP location, your request will be routed toward the appropriate backend. So here we can get URL-based routing, multi-site routing can be done. We can integrate custom domain certificate management can be done over here. Another important thing for security purpose, WAF can be integrated, the application firewall can be integrated. URL redirections and URL rewrite that needs to be there. Further, we have protocol support. It can also support IPv6 as well, and you can make the rule based on HTTP/2. It has different routing methods as well. Performance-based, geography-based, priority, that can be defined over here. So it's one of the commonly used and very popular big time load balancing service called Front Door. Next, we have another service that would be for inter-site connectivity. Here we are talking about ExpressRoute service. Now, when it comes to connectivity, we have peering, we have VPN gateway. Peering is a service which only used for Azure networks, and that relies on Microsoft backbone. But if I talk about ExpressRoute, ExpressRoute is something which offers you a dedicated connectivity to the Azure environment over Microsoft backbone. So according to this diagram, you can see this is on the left-hand side, this is your on-premises. And how do you want to make a connection to Azure environment using this ExpressRoute service? It's actually the collaboration between your ISPs, your partners, and your Microsoft network. I mean your Microsoft data centers. And those Microsoft ExpressRoute location is called, there we have Microsoft Edge Enterprises routers, MSEE routers are there. MSEE routers are there. Those routers have been kept at Microsoft ExpressRoute locations. So don't get confused between the regions and ExpressRoute locations. Azure regions and ExpressRoute locations are completely different. ExpressRoute locations contain this MSE router. And with the help of your ISPs, partner edge means with the help of your ISPs, we make these kind of connections. Now on this diagram itself, you can see that we are making dual connectivity, or we do have dual connectivity between the partners and the Microsoft. We have two connections that offers you high reliability, redundancy. So this ExpressRoute is fastest speed connection. This is the secure connection. This is highly reliable connection, and as well as it's going to be the costly connection as well. This is the fastest speed connection because it offers you the bandwidth or throughput up to 100 Gbps, between 10 to 100 Gbps. And as you can see, the two color differences like blue and red color, the red one represents the Microsoft pairing. Microsoft pairing means here we are talking about the connectivity for your PaaS and SaaS offering. When you say you need a dedicated connectivity using ExpressRoute to your PaaS services, to your IS, to your SaaS services, in that case, you can use Microsoft pairing for that. If you only have your networks to be connected using ExpressRoute, then you need to go with Azure private pairing. So it depends what type of pairing you want to configure. But that needs to be done with the help of your partner. First, you have to establish the connectivity with your ISPs, and then later you are going to set up these kind of functions. Once you set up your ExpressRoute circuit, you actually get one service key that is called S key. That S key needs to be shared with your providers. You share the key with them, and then they actually make the connections for you. As you know, ExpressRoute is the fastest speed connection. It's the most commonly used connection, and though it is costly as well. But what type of models are there for ExpressRoute? In which cases we use the ExpressRoute? We have 4 models over here for ExpressRoute. The first one is, these are the 3 models where we are using the service provider. That means ISP will be included. Point to point and any to any. These are the 2 models which is commonly used in organization. Point to point means here we are talking about your on-premises to Azure data center, ExpressRoute location. WAN. Here we are talking about branch offices. You have multiple branches, any to any connectivity. You have multiple branch offices to your Azure using the ExpressRoute service. This is called any to any connection. The first one called Cloud Exchange co-location. Here we are talking about using Exchange service like your SharePoint and all. You are using your Exchange location, Exchange service and Azure services together. That is called Cloud Exchange co-location. And these 3 services possible using ExpressRoute, using service provider model. We do have one more model that is called direct model. In this direct model, we are talking about, that means there are no ISPs in between. You are connecting directly to the Microsoft Global Network Pairing location, which is distributed across the world. That is called direct model. Overall, 4 models are there. 3 models are possible with the help of ISPs, and this model is called direct model. Okay, now with that, we are done with the second chapter. In this chapter, we discussed about the connectivity and NSGs, ASGs. We discussed about endpoint concept. NSG, I told you the demonstration we have seen